Welcome to Mr. Tompkins EdTech and my series of exam question compilation videos on key topics you might still be struggling with. This particular video covers functions. I've taken related questions from my past paper walkthroughs and given them to you here back to back. These compilation videos will give you a deep dive on topics you are still finding challenging, giving you more of an overview, helping you recognize command words, identify key features and strategies, building your confidence and helping you apply these techniques for future papers. If you find it helpful, please give the video a thumbs up. It will really help me out. Also, if you haven't already subscribed to my channel, why not do that now? I'll be making lots of these compilations over the next couple of weeks and you'll get notified of these as soon as I upload them. Right, let's get into it. Okay, question 4. I've given a function of x, f of x equals 8x minus 5, and I want to evaluate it for f of minus 2. So that means I just need to sub in minus 2 into the function. So 8 lots of minus 2 subtract 5. 8 lots of minus 2 is minus 16, take away 5 is minus 21. So it's that one there. In question 16, we're given the function f of x, which is equal to x squared minus the cube of x, and we need to circle the value of f of minus 3. Right, f of minus 3 is going to be where we take x and we replace it with minus 3. So minus 3 squared minus, negative 3 squared minus negative 3 cubed. Negative 3 times negative 3 is positive 9. Subtract negative 3 cubed, negative 3 times negative 3 times negative 3. Negative times negative is positive times another negative is negative again, isn't it? So it's negative 27. So 9 minus negative 27. And taking away a negative is the same as adding. So 9 plus 27 is 36. It's that one there, isn't it? Question 19. F and g are functions such that f of x equals 12 over root x and g of x equals 3 lots of 2x plus 1. Right, find g of 5. Okay, well g of 5 is just taking my g of x and replacing x with 5. So that's going to be 3 lots of 2 lots of 5 plus 1. Okay? So 2 lots of 5 is 10, plus 1 is 11, times 3 is 33. So g of 5 is 33. Gf of 9, that is like taking my 9 and subbing it into f, and then taking that and subbing it into g. Okay, so f of 9 is 12 over root 9. Which is 12 over 3, which is 4. So then taking that answer and feeding it into g, so g of 4 is going to be, so g of 4 is 3 lots of 2 lots of 4 plus 1. 2 lots of 4 is 8 plus 1 is 9 times 3, 27. Okay, so fg of 9 then is going to be 27. And finally, g to the minus 1 of 6. Now, g to the minus 1 is the inverse function of g. You can find the inverse function by rearranging the function first. So I'm going to say let y equal 3 lots of 2x plus 1. I'm just replacing g of x with y. I'm going to rearrange it and make x a subject first. So I'm going to do that first by dividing both sides by 3. So I'm going to get y over 3 equals 2x plus 1. I'm going to take 1 away from both sides. So that's going to be y over 3 minus 1 is equal to 2x. Running out of space here, let's just put a line here. And then dividing both sides by 2. So half of y over 3 minus 1 is equal to x. Can I tidy that up? Yeah, so I'm just going to do the half times y over 3, and that's going to be y over 6 minus a half then. That's going to be equal to my x. So then my inverse function, g to the minus 1 of x, is going to be that function. So I'm just going to replace back the y's with x's, It's going to be x over 6 minus a half. Okay, so then what is g to the minus 1 of 6? G to the minus 1 of 6, that's going to be 6 over 6 minus a half. 6 divided by 6 is 1, take away a half is a half. It's just going to be a half. Okay. Question 21. The functions f and g are such that f of x is equal to 3x squared plus 1 for all x greater than 0, and g of x equals 4 over x squared for x greater than 0. Work out g of f of 1. Okay, so part A says work out of g of f of 1. Now, g of f of 1, this is what we call a composite function. So you take one function, you sub it inside another one, and you kind of work from your inside going outwards. So starting closest to the number and working your way out, you can see you get to f first and then you get to g. So that means that f is inside g. So you start with f of x and then you put whatever your answer is and you put it inside g of x. Okay, so g of f of 1 is that you're going to start with f of 1 and work that out. So what's f of 1? F of 1 is equal to 3x squared plus 1. So that's going to be 3 lots of 1 squared plus 1. Well, 1 squared is 1, times 3 is 3, plus 1 is 4. Okay, so f of 1 is 4. So then what you're going to do is you're going to take the answer for that and you're going to feed it inside g. So basically we need to work out what g of 4 is then. So we're going to take the output of f and we're going to put it into g. So g of 4 then is going to be 4 over x squared, which is 4 over 4 squared. Okay, which is 4 over 16, which is a quarter. Okay, so then g of f of 1 is going to be 1/4. Right, for part B, we're told that the function h is such that h equals f of g to the minus 1, and we want to find h of x. Okay, so again, working backwards, look, this means take the function g and sub it inside of f. Okay, so h is going to be this function here, the 4 over x squared, written where the x appears there in f of x. Okay, so in other words, I'm just going to write fg of x to start with. Fg of x is going to be f of x, 3, well, where the x squared would be, plus 1, I'm going to replace that x with what g of x is. So it's going to be 3 lots of 4 over x squared all squared. Okay, so rather than 3x squared plus 1, which f is normally, it's 3 lots of that g of x function all squared plus 1. Okay, hopefully that makes sense. And then so removing the brackets, I kind of have to square both bits, don't I, when you've got a bracket squared like that. So I need to square 4 and square x squared. So I'm going to get 4 squared is 16, and then 16 times 3, 16, 32, 48. 48 over, and then x squared all squared, that's x to the 4. So I'm going to get 48 over x to the 4 plus 1. So that's what f of g of x is. Now, when I want to find h of x, I need to find the inverse of that function. So h of x is going to be the inverse of what I've just found. Okay. Now, to find an inverse, what I normally do is I say let y be my function that I want to find the inverse of, and then I rearrange it for x, and then I rewrite the y's back for x's again. Okay, so we start off with y equals 48 over x to the power 4 plus 1. I'm going to make x the subject. So the first thing I'm going to do is going to subtract 1 from both sides. That's going to give me y minus 1 is equal to 48 over x to the power 4. The next thing I'm going to do is I'm going to times both sides by x to the 4 and divide both sides by y minus 1, which will have the effect of switching these two around. Also, if you just know about cross multiplying, then you might probably already be comfortable with just switching those around like I am. So that's x to the 4 is equal to 48 over y minus 1. Just swapping those around using cross multiplication. And then to get x by itself, then I'm going to have to take the fourth root then of that. So x is going to be the fourth root of 48 over y minus 1. Okay. Now, in order then to find the inverse function h of x, I'm going to take the format of that answer, but I'm going to replace x with h of x, and I'm going to replace y with x. So h of x is going to be the fourth root of 48 divided by, I'm just going to write x instead of y, x minus 1. Okay, that's kind of how I do it. And I think that's the answer. The fourth root of 48 over x minus 1. Well, not a very nice answer. 22, f of x equals 3x and g of x equals x squared. Circle the expression for fg of x. Okay, now with function notation, you always start in the middle. So I'm starting with g of x, and then I'm taking g of x and I'm subbing it into f of x. Okay, in other words, I'm going to take x squared from here, and I'm going to write it where I see the x here in f of x. Okay, so my fg of x is going to be 3, but rather than writing x, I'm going to write the expression for g of x, which is x squared, and that's just going to give me 3x squared then, isn't it? So it's that one there. Question 21, f of x is 3x plus 9 over 5 and g of x is 6x minus 1. Show that g of f of 2 is an integer. Okay, well, g of f of 2 means take 2, put it in function f, and then whatever you get out of function f, you feed into function g. Okay, so if you want to picture it, 2 is going into f of x, and then whatever comes out of f of x is going into g of x. Okay, and then we want to find out what the output is. Okay, what is the output after that? I wrote a really weird 2. Let me just write that down because it's offending me. So yeah, so 2 goes into f of x, then whatever comes out of f of x after 2 went in goes into g of x, and whatever comes out of that is our answer. We need to show that's a whole number. Okay, so let's do that. So let's work out f of 2 first. F of 2 is 3 lots of 2 plus 9 over 5. Just replacing the x with the value of x, which is, in this case is 2. So 3 lots of 2 is 6, plus 9 is 15. So that's 15 over 5. So I'm going to get 3 out. So 2 goes in and 3 comes out. Okay. So because 3 came out of f of x, that is what I'm feeding into g of x. So I'm working out now g of 3. So g of 3 then. So if I feed g into g of x, and that's 6 lots of 3 minus 1 then, isn't it? So 6 3s are 18, take away 1, that's 17. So therefore, g of f of 2 is equal to 17. So I have shown it is an integer. It is an integer. Yeah, integer just means positive or negative whole number. 21b says show that f to the minus 1 of 8 is not an integer. Okay, so what is f to the minus 1 first off? If f of x is equal to 3x plus 9 over 5, what we do to find the inverse function is we replace f of x with y, and then we rearrange for x. So rather than writing f of x equals this, I'm going to say y is equal to this, and then I'm going to rearrange and make x a subject. So times in both sides by 5 to start with, I'm going to get 5y equals 3x plus 9. Taking 9 away from both sides, I'm going to get 5y minus 9 is equal to 3x, and then dividing both sides by 3, I'm going to get x is equal to 5y minus 9 over 3. Okay, so therefore f to the minus 1 of x, I'm just going to take this expression 5y minus 9 over 3. Now that's going to be my inverse function, but I'm going to replace the y with the x because I don't have any y's when I'm dealing with function notation. It's just all about x. So I'm just going to replace the y with the x, and then that is my inverse function. So if I feed a number into f of x and get a number, if I then take that number and feed it back into f to the minus 1 of x, I'll get back what I started from. Okay, so now I need to show that f to the minus 1 of 8 is not an integer. So what is f to the minus 1 of 8? Well, it's going to be 5 lots of 8 minus 9 divided by 3. So 5 eighths are 40. Take away 9, that's 31. 31 over 3, that's going to be, well, it goes in 10 times remainder 1, isn't it? It's 10 and a third. Okay, so therefore, f to the minus 1 of 8 is not an integer, because it's got a third on the end. Question 22. f of x equals 2x squared and g of x equals x plus 5. Circle the composite function f g of x. So that's where we're taking g of x and substituting it into f of x. So we're going to rewrite this where we see the x above. So fg of x is going to be 2 lots of x plus 5 all squared. So it's that one there. Question 24. f of x equals sine of x minus 90. Circle your value of f of 0. Okay. So this is defined in function notation. So f of 0, then you're replacing the x's in the expression with 0. So f of 0 is going to be the sine of 0 subtract 90. In other words, it's going to be sine of negative 90. Okay, right, do you remember what the sine curve looks like? Okay, if I draw a sine curve, it starts at 0, doesn't it? It kind of oscillates like this. Okay, and you should remember that the period of that is 360 degrees. It takes 360 degrees to go through a full oscillation, which means that's 180 and that is 90, and so on. So that's 360. And so in the middle is 270. Not that we need to know that. What we need to know is what the value of sine to the minus 90 is. Okay, so if it goes like that and it oscillates, it's also going to repeat on the opposite side of the equal sign, so it's also going to do that, and it's going to kind of work backwards that way as well. So if the distance from there to there is 180, then the distance from there to there is also 180, so that number there is minus 180, and then halfway in between is going to be minus 90 then, isn't it? Okay, which is the lowest point on this sine curve. Now sine oscillates between 1 and minus 1, so I can see that the sine of negative 90 is going to be minus 1, so I'm going to go for that one there. Question 24a, got some function notation here. It says f of x equals cx plus d, and then we're given two specific values. We're given f of 4 is equal to 7 and f of 10 is equal to 22. Okay, so f of x equals cx plus d. So presumably c and d are two constants that we can go and find. Yeah, so we're going to go and find them here, aren't we? Okay, so we don't know what they are yet, but we do know that f of 4 is equal to 7. Well, f of 4 is c lots of 4 plus d, isn't it? Okay, in other words, it's 4c plus d. Okay, now we know that 4c plus d must be equal to 7 because we're told it here, aren't we? F of 4 is equal to 7. So I've got one equation now in c and d. If I'm going to do the same thing for f of 10, this one here, so I'm going to know that f of 10 is equal to 10c plus d, and I know that that is equal to 22. So if you have a look at this bit here, then what we've got here is a pair of simultaneous linear equations in c and d, which we should now be able to go on and solve. Okay, so what I'm going to do is I'm going to subtract one from the other. So now notice I've got a d and a d, so they match. So if I take one away from the other, then the d's are going to cancel. Now I hope you can excuse me, I'm going to kind of subtract uphill, if you see what I mean. I'm going to take the first equation, the 4c plus d equals 7, away from the second one. So I'm going to do 10c take away 4c, which is 6c. I'm going to do d take away d. Well, they cancel each other out, don't they? And then I'm going to do 22 take away 7, and that is equal to 15. So I get 6c is equal to 15. Dividing both sides by 6, that tells me that c equals 15 over 6, which is the same thing as 5 over 2, which is the same thing as 2.5. So c is 2.5, 2.5. Okay. And then once I know what c is, I can then sub it back into one of my original equations up here. I've got 4c plus d equals 7. So substituting back in, c equals 2.5. Let's call that equation 1 and equation 2. So subbing c equals 2.5 into equation 1, then I'm going to get 4c, 4 lots of 2.5, plus d is equal to 7. Well, 4 lots of 2.5, that's 10, isn't it? 10 plus d is equal to 7. So taking d away from both sides, that tells me that d must be negative 3. So I've got c is 2.5 and d is negative 3. Question 24b, g of x is defined to be 2x and h of x is defined to be x minus 1 over 2. Circle the expression for hg of x. Now hg of x is what we call a compound function. What we're going to, when you read these from kind of like the inside out, so if you think about it, I've got g of x, which is then substituted inside of h of x. So what you do is you take g of x, like this bit here, the value of g of x, and you rewrite it where the x is in h of x. Okay? So what I'm going to do is I'm going to take the expression, so hg of x, I'm going to take the expression for h of x, but I'm going to replace x with g of x, which is 2x. So rather than having h of x is equal to x minus 1 over 2, I'm going to have hg of x equals, rather than x, I'm going to write 2x minus 1 over 2, because I replaced where the x is with the value of g of x. Okay, so which one is that? It is that one there. Question 25, f of x is equal to 2x plus 5. Show that 3 lots of f of x minus 12 lots of f to the minus 1 of x simplifies to an integer. Okay, right, now before I go on and do this bit down here, I just want to know what this bit here is, f to the minus 1 of x. Now that's the inverse function of x, isn't it? Okay, and I can find the inverse function like this. If I say y is equal to my function in the x, 2x plus 5, and then I change the subject of the formula into making it x. Taking 5 away from both sides, I'm going to get y minus 5 is equal to 2x. And then if I divide both sides by 2, I'm going to get x equals y minus 5 over 2. Okay? Now that tells me then that the inverse function, f to the minus 1 of x, I'm just going to take y minus 5 over 2 and I'm going to replace y with x. So I'm going to get x minus 5 over 2 like that. Okay? So that's if you want to find the inverse function, write down y equals the function, rearrange it to make x the subject, and then rewrite what you find, but replace the y back with the x. And then that will give you your inverse function. Okay? So that's what f to the minus 1 of x is. Okay, so now I can work out and I can show that the thing it wants me to find. Okay, so I'm going to show that 3 lots of the function minus 12 lots of the inverse function simplifies to an integer. Okay, so let's do that then. So what's 3 lots of f of x minus 12 lots of f to the minus 1 of x? That's going to be 3 lots of this thing up here then, isn't it? 3 lots of 2x plus 5. Okay, minus 12 lots of this thing over here. Okay, x minus 5 over 2. Yeah? Right, let's just simplify that out. Multiplying out the bracket. Going to get 6x plus 15 for the first bracket. With the second one, I'm just going to divide that 2 into the 12 first and get 6. And then I can just multiply that 6 out on those two terms. So I'm going to get 6x. Now I've got minus 6x times minus 5, so that's going to give me plus 30. So just take care with those signs at the end there. Okay, so now you can see I've got two types of things here. I've got terms in x that spookily are equal but opposite signs. So they're just going to cancel each other out, aren't they? 6x times minus 6x, they're going to disappear. And I'm left with 15 and 30 that I can add together. And that is going to give me 45. Okay, so we can see then that it does simplify to an integer because all the terms in x disappear and I'm just left with the number. So yes, it does simplify to an integer. Question 26. We're given two functions. G of x, we are told, is equal to 16 minus x, and h of x is equal to x cubed. And we're asked to solve gh of x is equal to 24. Okay, so this is a compound function, isn't it? And the way it works is you have to kind of work from the inside outwards. So we're going to start with x cubed, and then we're going to sub it into g of x. We need to take this equation here for h of x and put it in where the x appears in g of x. So we're going to take our value of x, we're going to cube it, and then we're going to take it away from 16. That's basically what's going to happen, isn't it? So let's do that then. Let's just sub that in. So gh of x then is going to be 16 minus x cubed. Now we're told that that is equal to 24. So what value of x makes that true? Well, I think probably the easiest thing is if I take that x cubed and move it to that side, that will make it positive. And we can take this 24 and move it to this side. And we're going to get 16 minus 24 is equal to x cubed. So 16 minus 24 is 8. Well, it's minus 8, isn't it? And that's equal to x cubed. So then we need to cube root minus 8 to find x. Cube root of minus 8, negative 2. Okay, in question 26, I've been given two functions of x. F of x equals x squared plus 1 and g of x equals x minus 5. I need to show that f of g of x is that expression there. Now, f of g of x means take g of x and put it inside f of x, which basically means wherever I see x in my f of x expression, like here, I need to replace it with that expression. So I'm going to take my x squared plus 1 and insert x minus 5 in where I see the x. Okay, and then I need to multiply that out. X minus 5 all squared. Now last time I did this, I did it the long way, but this time I'm going to use the identity. If I've got a minus b all squared, then that is a squared minus 2ab plus b squared. This is a very useful identity to remember. It makes it multiplying out these things a lot quicker and easier. So that gives me x squared minus, so 2 times a times b in this case would be minus 10x plus 25 plus 1. So then just join in those last two things together. Gives me that. So, done. Now part B says solve fg of x equals gf of x. Okay, so we've already worked out what fg of x is. what's gf of x? So gf of x is equal to, well, we take our function of f of x and we feed it into our g of x. So this time round, our x is here and we're going to replace it with this expression. So that is going to sit where that is in there. So I'm going to get x squared plus 1, my x, take away 5, which is x squared minus 4, isn't it? Okay, now I need to solve fg of x equals gf of x. Now we just showed that fg of x is x squared minus 10x plus 26. So x squared minus 10x plus 26, and we now know that's the same thing as x squared minus 4. Okay, so our x squareds cancel, and we are left with minus 10x plus 26 equals minus 4. Okay, so I'm going to move the minus 10x to this side, and I'm going to move the minus 4 to this side. So that gives me 26 plus 4 is 30 equals 10x. So x equals 3. Question 26, f of x equals x over x plus 2 and g of x equals x squared minus 2. Work out f of g of x. Give your answer in the form a plus b x to the power n, where a, b, and n are integers. Okay, so basically I've got to take function g and sub it into function f. You kind of work from the inside out for these. So closest to the x is this g here. So that means I've got to take this expression for g and I'm going to sub it into f. Okay, it's going to go into f. So I'm going to rewrite this expression wherever I see x in this expression. Okay, so that's the plan anyway. So fg of x is going to be x, but this time I'm going to replace x with x squared minus 2. So writing x squared minus 2 where the x used to be, divided by, I've got another x down there, so I've got another x squared minus 2 plus 2, because that was there before. Okay, so just removing the brackets. So I've got x squared minus 2 on the top, divided by x squared minus 2 plus 2, which is just x squared. Okay, now it's not quite in the form we need it in. We need it in the form a plus b lots of x to the power of n. Okay, where I've got a fraction over x squared at the moment. Okay, so I'm going to break this up into, I've got an algebraic fraction, I'm going to break it up into 2 halves. So x squared minus 2 over x squared is the same thing as x squared over x squared minus 2 over x squared. Okay, now x squared over x squared is just 1, isn't it? Anything divided by itself is 1. And I've got minus 2x squared. Now I can rewrite that as a negative index. I can say that that is equal to 2x to the minus 2. Okay, using negative indices. And now I've kind of got it in the form I wanted it to be in. Okay, so having a look back up at the top there, look. A is now my 1. B is my minus 2. And n is my negative 2 up there as well. Okay, so I've got integers for all those. It's all in the right form. I'm good. Let's move on. Question 26, we're given a function in x as 2x plus 3 over x minus 4, and we need to work out f to the minus 1 of x, or the inverse function. Now, the technique for doing this is just start off by replacing f of x with y. So make it y is equal to 2x plus 3 over x minus 4. And then try to change the subject of the formula. So you make y the subject rather than x. That's the first step anyway. So let's start off by cross multiplying this denominator over to the other side. So I get y x minus 4 is equal to 2x plus 3. Removing the brackets, I'm going to get xy minus 4y is equal to 2x plus 3. Okay, what am I trying to do? I'm trying to get make x the subject of this formula. So then let's move that to this side, move this to this side. I'm going to get xy minus 2x is equal to 4y plus 3. Next thing I'm going to do is factorize the x out of these two terms. So I'm going to get x y minus 2. The reason for that is I need to have one instance of the x. That's why I'm bringing them to both sides and factorizing. I need to try and just get one x because I want to make x a subject. Okay, and now what I can do is then just cross multiply this back down there. So I'm going to get x is equal to 4y plus 3 all over y minus 2. Okay, so now I've got x in terms of y. I can just say that f to the minus 1 of x is equal to, I'm going to write the same expression down, but I'm going to switch back the y's back into x's. So I'm going to say that 4x plus 3 over x minus 2 is my inverse function. So from the top then, I replaced f of x with y. So I had an equation in y. I then changed the subject from y to x, and then I replaced my y's back again with x's, and then that is your inverse function. Anyway, let's move on. Question 7. I've been given a function f of x is equal to 2x over 5 minus 1. Work out the value of f to the minus 1 of 3 plus f of minus 0.5. Okay, now this expression here is for the inverse function of f. Now the easiest way of finding an inverse function is taking your function f of x and rewriting it in terms of another variable. So like instead of writing f of x, I'm just going to write y. So y is equal to 2x over 5 minus 1. Now we rearrange it and makes x a subject. So I can do that by adding 1 to both sides first off. So I'm going to get y plus 1 is equal to 2x over 5. And then cross multiplying the 5. So moving that up there, I'm going to get 5 lots of y plus 1 is equal to 2x. And then divide by that 2. So I'm going to get 5 over 2 lots of y plus 1 is equal to x. Okay, so that's my expression of y in terms of x. And then you can just replace x with f to the minus 1 of x and rewrite what you've got on the left in terms of x instead of y. So I'm just going to rewrite that as 5 over 2 open brackets x plus 1. Okay, so that's the easiest way of doing it. So you just take f of x, rewrite as y, rearrange to make x a subject, and then replace your y in your rearranged thing back with x, and that will be your inverse function f to the minus 1 of x. Okay, now I know what the f to the minus 1 of x is. I can now evaluate that expression f to the minus 1 of 3 plus f of negative 0.5. That means I need to sub 3 into my inverse function of x. So take in this thing here and sub in 3 into it. I'm going to get 5 over 2 of 3 plus 1. Okay, and now obviously that can simplify a bit in a minute, but I've got a bit more to do. Plus, I'm now going to take this minus 0.3 and sub it into our original equation, f of x equals 2x over 5 minus 1. So 2 lots of negative 0.5 divided by 5 minus 1. Okay, let's see if we can simplify some of this now then. In that bracket I've got 3 plus 1, which makes 4. 4 times 5 is 20, and 20 divided by 2 is 10. So that first bit becomes 10. What have we got on the other in the next part? Plus, well, it's going to become negative, isn't it? So I've got 2 times negative a half, which is negative 1, divided by 5. So that is minus a fifth. And then I've got minus 1 on the end. Okay, so what's that then? 10 minus 1 is 9. 9 minus a fifth is 8 4/5. Or 8.8 if you'd rather. And I think that with that we're done. Yeah, end of questions. Hurrah. Work out f to the minus 1 of x. So we want to find the inverse function of f. Now the quickest and simplest way of doing this is, let's just make it an equation first. Y equals 4x minus 3 over 5. And then rearrange to make y the subject. So moving that over there, going to get 5y equals 4x minus 3. Moving the minus 3 over next, I'm going to get 5y plus 3 equals 4x. And then finally, cross multiplying the 4, I'm going to get x equals 5y plus 3 over 4. Now what we can do is then just rewrite that. So f to the minus 1 of x is equal to that expression again, but rewritten with the y's replaced back for x's. So I can just rewrite that and say, well, that's 5x plus 3 over 4. Question 7, we've got a question on function notation here. We're told that h of x, the function h of x, is equal to the cube root of x for all values of x. On the grid, draw the graph of the inverse function h to the minus 1 of x for values of x between minus 2 and 2. Okay, now to find an inverse function, if we let y equal our original function, and then rearrange for x, and then replace the y's with the x, we can come up with the inverse function. So what's the opposite of cube rooting? I need to cube both sides, don't I, to get x by itself. So y cubed will be equal to x. So I can say that the inverse function, h to the minus 1 of x, is going to be x cubed. So I need to draw that function, y equals h to the minus 1 of x, between minus 2 and 2. So if we draw a quick table of values, so from minus 2, minus 1, 0, 1 and 2 for x, then h to the minus 1 of x is going to be the cube of those. So minus 2 cubed is minus 8, minus 1 cubed is minus 1, 0 cubed is 0, 1 and then 8. Okay, so minus 2 minus 8 is down here. Minus 2 minus 8. Minus 1 goes with 1, 0, 0, 1, 1, 2, 8 up there. Okay, so now again we draw a nice smooth curve going through the center of each of our points. We're going to get that distinctive S shape of a cubic. Some cubics are a bit more turny in the middle, but when you've got no other coefficients like that, it's normally less pronounced, like this one. Okay. And then 27b, for all values of x, f of x is equal to the sine of x and g of x is equal to x plus 90. On the grid, draw the graph of the composite function y equals f of g of x. So that means we need to take our function g of x and substitute that in where we see the x in f. So fg of x is going to be the sine of x plus 90. Oh, they haven't given us a nice sine curve to translate. Basically, this is going to be a translation of your sine curve, isn't it? Now, a normal sine curve starts at 0, 0. It goes up to 1 at 90, and then back down to 0 at 180, and then down to -1 at 270, and then back up to 1 at 360. So a normal sine curve looks like this. Now this is going to be a translation of the sine curve. Now what we're doing is we're replacing x with x plus 90. So this is a translation, isn't it? It's a translation of x. And it's 90 units to the left. Okay, it's always the opposite way as what you might think when you sub inside the function rather than in the direction of x than in the direction of y. So basically we're going to take each of these points, we're going to translate it 90 units to the left. So this point here is going to be it now there at minus 90. That point that was at 90 is going to be at 0. That point is going to be here, and then here, and then here, and then we're going to have another one up there. So basically we're going to get something that looks like the cosine curve, aren't we? That's the graph that we're going to draw. Okay, good to sketch it out like that first so we know what we're doing, so don't make a complete dog's breakfast of the graph paper we're given. So it's going to start here then, and then go through here, then through here, and then through here, and end up there. Okay, drawing our cosine curve in, or sine x plus 90. It's going to look like that. Kind of missed the point there. I think I'm going to redraw that one. Okay, that's a bit better. Oh yeah, and can't have a break in my curve. Okay, I'm happy with that. Question 28. f of x equals 5 minus x and g of x equals 3x plus 7. So we're asked to simplify f of 2x plus g of x minus 1. Okay, so basically when you've got something inside the bracket, that is the value that you're giving to x. So here f of 2x is going to be 5 minus, going to sub in 2x for x. So that first part is going to be 5 minus 2x, and then plus g of x minus 1. Where I see x, I'm going to write x minus 1. So I'm going to write x minus 1 in there, just like I wrote 2x in there for the first one. So 3 lots of x, which in this case is x minus 1, plus 7. Okay, so simplifying that, I've got 5 minus 2x, multiplying out the brackets, plus 3x minus 3 plus 7. Collecting like terms, I've got minus 2x plus 3x, which is x. And I've got 5 plus 7, which is 12. Take away 3, which is 9. So x plus 9. So it simplifies to x plus 9. Question 28b says solve g to the minus 1 of x is equal to 2x. Now g to the minus 1x is the inverse function. Okay, now we learned earlier that g of x was 3x plus 7. So if g of x is 3x plus 7, and we want to work out what g to the minus 1 of x is. Now let's take that equation 3x plus 7, or that function, and put it equal to y. I'm going to rearrange it for x and then reform the inverse function from that. So 3x plus 7 is equal to y. Let's subtract 7 from both sides. You're going to get 3x is equal to y subtract 7. And then dividing both sides by 3, I'm going to get x is equal to y minus 7 over 3. Okay, so I've made x a subject. So from that, I can tell that the inverse function g to the minus 1 of x is going to be equal to, I'm just going to take this expression here, y minus 7 over 3, and I'm going to rewrite it, but with that one replaced back with an x. So I'm going to write x minus 7 over 3. Okay, so that's my inverse function g to the minus 1 of x. Right, now we're told in the question, or we're asked in the question, to solve g to the minus 1 of x is equal to 2y. So I'm going to take this expression I've just made for g to the minus 1 of x and equate it with 2x. So x minus 7 over 3 is equal to 2x. Okay, now we just need to solve for x. So multiplying both sides by 3, I'm going to get x minus 7 is equal to 6x. Subtracting x from both sides, I'm going to get minus 7 is equal to 5x. So then x is going to be minus 7 divided by 5 then, isn't it? Okay, question 30. The paper's finishing with some function notation. I've got f of x is equal to x over 3 plus 4, and g of x is given as 6x squared plus 3. And we need to work out fg of x. Now, with these, you start on the inside and work outwards. So the first function is you take x and you put it in g, and then that then is fed into the function f. Okay, so the first thing to do is we're going to take our function for g of x and we're going to feed it into where we see the x in f of x. Hopefully that makes sense. So fg of x is, so I'm going to, where I see the x in f of x, I'm going to write g of x. So that is 6x squared plus 3, all divided by 3 plus 4. So you can see what I've written in, what I've got here is here, and I've written it there where the x is in f of x, and the rest of what I've got divided by 3 and plus 4 is there. Look, hopefully that makes sense. So fg of x is 6x squared plus 3 all over 3 plus 4. Okay, now it's not quite in the form thereafter. I want it in the form ax squared plus b, and I've got a kind of more complex looking thing going on here. Now, let's see if we can simplify this out. Well, first off, 6x squared plus 3, that factorizes, doesn't it? I can take 3 out as a common factor. So that's actually 3 lots of 2x squared plus 1 divided by 3 plus 4. And you'll see that the reason I've done that is that I can then just cancel those 2 away. 3 divided by 3 is 1, so I just end up with the bracket. So that becomes 2x squared plus 1 plus 4. And then add in my 1 and my 4 together. I'm going to get 2x squared plus 5 as the final answer. So that is in the right form. Look, 2x squared plus 5 is in the form ax squared plus b. So a is 2, b is 5. Okay. Question 30. F of x is a half of x and g of x is x minus x squared. Solve the inverse function of x is equal to g of f of x. Okay. Right. So we've got a few things to do here. First off, we need to know what f to the minus 1 of x is. We've been given f of x, so we should be able to find what f to the minus 1 of x, the inverse function, is. Right, so what I'm going to do is I'm going to say that y is equal to a half x. Okay, and I'm going to rearrange and make x the subject. So timesing through both sides by 2 times 2 times 2. I'm going to get x is equal to 2y. Okay, just spin that around, x equals 2y, and then replace x with f to the minus 1 of x, and replace y with x. So I get f to the minus 1 of x equals 2x. Okay, so that is the inverse function of f of x. Now we want to also know what g of f of x is, so I'm going to do that as well. G of f of x. Now that means take f of x and stick it inside g of x. Okay, so what we're going to do is we're going to, every place we see an x in g of x, we are going to sub in f of x, which is this expression here, half of x. Okay, so g of f of x is going to be, I'm just going to rewrite that as x over 2 because I find that easier than half x. It seems to be a lot of extra work. So I'm going to say that half x is x over 2. It's the same thing. So x over 2, replacing x with half x, minus x over 2 squared then. Okay? So what I've done, like I say, is I've taken f of x and written it where I see x in g of x. Okay, then I need to simplify this. So the first thing is just x over 2 minus x squared over 4. Okay, so that's my expression for g of f of x, and I've already got my expression for f, the inverse function f of f to the minus 1 of x. So if I'm saying that these two things are the same, f to the minus 1 of x is equal to g of f of x, then what I'm saying is that this thing here is equal to this thing here then, isn't it? So I'm going to equate them basically. So I'm going to say that 2x is equal to x over 2 minus x squared over 4. Okay, now can you see I've got horrible fractions everywhere, which can easily be resolved by multiplying everything through by 4. Okay, I'm just going to multiply everything through by 4. That will get rid of all my fractions in one go. Okay, so I've got 2x times 4 is going to give me 8x. X over 2 times 4 is going to give me 2x. And x squared over 4 times by 4 is going to give me x squared. They're all gone. Right, so you can see my x squared term is negative, so I'm going to kind of move everything over to the other side, aren't I? By adding x squared and taking away 2x. That is going to give me x squared, 8x minus 2x is 6x is equal to 0. Okay, hopefully you can follow that. I'm just adding x squared and taking away 2x from both sides in one go. That was a very weird 0. Right, so then what am I going to do? I'm going to factorize x plus 6 is equal to 0. That tells me that x must be 0 or x must be minus 6. Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.